The Rideau River, and more importantly, the Rideau Canal, which was built by the British Admiralty to circumvent the St. Lawrence River after the War of 1812, is a rather substantial river. It was used by Native Indians, and Ottawa, which this river actually ends in and is near Parliament Hill, is a significant river. And these sorts of rivers produced the very first power that was utilized by early settlers, such as they did at Watson's Mill. And I think what's interesting here is we can watch, and I'll take you through the building as we grind flour, and turn this river power into mechanical power through mechanisms and line shafts and turbines. The structure was state-of-the-art for 1860 and an absolutely marvelous example of sort of British colonial industrial architecture. Very glad to be working on it. Now here we're entering the main floor, and you notice it has plastered walls and turned Doric columns. This is quite extravagant for these types of mills. So here we are, we're looking at the first thing. The wagon would come in and throw stuff into the hopper. And the museum often lets children turn the turbines on. And so what we're turning on here is the elevators that will take the grain that you drop into this hopper and carry them up to the very tip of the attic. Now, what I think is fun about the museum is often the people that walk through this don't completely understand the way that the grain travels through the building and is turned into grist or flour. And here the elevators start to move with the help of the museum staff. And we can see that once the stone is turning, which isn't yet, it will direct its flour to this elevator. So that turbine is only a 15 horsepower, and it carries the grain up to the third floor and consequently all the way to the grinding mill. And so here they are opening up grain to dump into the hopper that would have come in by the front door on wagon. And the operation of this mill happened all the way up to the 1950s before it was taken over by the Rideau Conservation Authority and consequently transferred to the museum. And Watson's Mill Inc. now operates. And I, so far, have been the lucky millwright to rebuild the entire mechanism, make sure it operates. Now, once she has loaded the grain, she's adjusting that little handle right there to allow the proper amount of grain to fall through. Now, this elevator and this work will handle it much faster than that. But it's done in such a way that during the operation of the flour milling, spectators can see that sort of in action. And what she's looking for is the grain to show up in the buckets. Now, if I am to, follow where that grain goes, Chris Ennis there, the master miller, is dropping in the hopper. And let's follow this grain and throughout the building and see how its mechanisms are done. Chris is throwing grain into the stone to charge the stone before starting the stone. So the stone is not spinning yet. The turbine for the stone is not on yet. He's just getting grain delivered through those hoppers. And he's just starting to turn that on. And there it is, the work that we performed this winter placing the teeth, setting the bearings, and whatever you watched during the thing and during this season's operations. I'll be here all season, fine-tuning, selecting. There's the turbine pumping water directly under that shaft, and that work is directly under the stone that Mr. Chris Innes, the master flour miller, is operating. Now there's two levers here. The short one operates the space between the runner stone and the fixed stone. So there's a stone embedded in the floor, and there's the runner stone, the one that's spinning, and that changes the space between them and consequently the grit of the flour. The hand wheel that is Chris's hands are on right now control the gate for the turbine, which allow either more water to come in to increase the power or reduce the power. And so Chris is going through, and this is a fine-tune process. It takes, maybe a bag of flour to get it to just be the right texture. This little apparatus can be adjusted to rattle a certain amount of grain, and so that it becomes an automated process. And that was really the whole idea behind this sort of technology. Up until then, many people just did all of this by hand. And so, they gloated about this operation, and this technology could be operated by a single individual. And this mill had up to 4 stones in operation and 6 turbines. So as Chris fine-tunes the speed of the stone, the texture of the flour, and you can see it's getting less coarse, and he gets to a certain fineness to where he can mill up to 100 to 150 pounds in an hour or so. And this is really actually quite small. So that hopper upstairs, which you saw them dump the grain in, drops down into the basement, sub-basement in this elevator, and you can see those buckets that we saw her seeing if they were collecting grain are picked up here. Now there would have been other chutes in the original one, but there's only one now for that. And here we are watching the wooden tooth gear that drives the 2-ton runner stone in operation, and the chute where that flour was coming out, entering into the elevator for the flour, which is traveling all the way up through the floors. Now this is sort of necessary that they travel that far, because the stones sort of warm the grist and it makes it kind of sticky, and so it has to be cooled in some way. And so it just traveling over a long distance. Here's the second floor, and that's the grain elevator, and this is the flour elevator. Continue up into the 3rd floor, which there is still the upper attic with these elevators actually terminate into. And that was the turbine that kid was opening up to operate the grain elevators. And here's the mechanism we built many years ago that helped convey that flour. And here it comes up into the attic and now shoots out of there. Once again, this is maybe 300 feet, and we are well above the river now. We're up in the very tips of the attic space. It now goes through this auger, which cools the flour and turns it and makes it less sticky, and gets the sheath of the grain separated from the the white parts of the flour. Now, what's fun to watch is the mechanism of how it's transferring all of these things to drive the pulley that is at the top of this, which carries the grain elevator, which the grain dumps out of it and goes all the way over and drops down into the floor here. Now there would have been diverters for all different types of grain, and so this one drops into here, and there's another hopper that is just directly above Chris Innes downstairs and gives him the grain for the stone. The flour drops out of that cooler and into the bolter, which is another form of cooling, but more importantly, it sifts out the flour from its coarse husk and germ and drops it into the floor. And this mechanism that we rebuilt a few years ago is also coming up from the turbine, which is a third turbine in the museum that operates the duck feed. Now, after the bolter is filtered, there's 3 levels of fineness of flour. They drop down through the floor. Here you can see that from that hopper for the grain coming out of what I showed you upstairs and loading it into here. And Chris can control how much grain drops into the hopper by a couple of levers. And we can see that Chris has got this looking really good. As I said, Chris Innes is the master miller at Watson's Mill and is amazing. And here, the final product, that is the waste that we want to get rid of, and here is the flour completed. Anyway, that's following the graining and the milling at Watson's Mill, Manotick, and Chris Innes, the master miller. Thank you.